So now that you've had the area review, it's time to start talking about the volume of some of these 3D solids that we're going to talk about in Chapter 12. The first one we're starting with is cylinder. So a cylinder is a circle, stretch up, stretch up, stretch up, another circle, and the two circles are congruent. So these two circles are exact copies of each other. They're called the bases. Now you can be knocked on its side like this, or you could have a cylinder standing upright like this. Okay? Um, if you look, what this is talking about here, what this is trying to say is, if you take a rectangle like this, like a normal sheet of paper, if you were to just roll it up, you would make it into look like a tube, like a cylinder, right? Well, this side would form a circle if you did that, and this top and bottom circle would be congruent, and those would be the bases, just like in this picture and in this picture. And so that's what this is talking about, how the base is 2 times pi times r, that's the circumference of the circle, and then the height is here, right? So we're going to talk about the volume formula for cylinders and how it relates to prisms. But as we do all the different solids, we're also going to talk about things called cross sections. So remember, all these objects that we're talking about now are 3D. Okay, they're not just flat objects; they're three-dimensional objects. A cross section is if you take a plane, take a flat surface, okay, force field, super sharp blade, cut through part of the solid, okay, and chop some of it away, and then look at what's left. That flat piece that just got created is called a cross section. So if you look here, look at this first example with cylinders. You have a cylinder standing upright, okay? If I cut parallel to the base, so imagine if this thing here is a blade, and pretend this cylinder is a solid block of ice, okay? This blade here, this plane, cuts through the middle of it, right like that, parallel to the bases, and then you took the top part of this cylinder and threw away. Now look at the new top of the cylinder, and what would it be? Well, wouldn't it be this circle? So the cross section would be a circle. That's this shape that you can see right here when you cut the top of the cylinder off. Okay? Now, if you were to slice perpendicular to the bases, so look, if I slice down this way through a cylinder, and then I took this part and threw it away, and now just look at the new edge I just created, I would see this cylinder. Okay? So picture like a Pringles can cut through the middle, the top of it this way. Throw half the Pringles can away, and now look at it, you're looking at a rectangle. Okay? If you cut in diagonally through a cylinder like this cross section here that you create is kind of like a stretched out circle if you look at it. It's not the exact same circle here like it was when we were parallel to the base. Okay? It's like a stretched out circle, kind of like an oval. We call that an ellipse. So these flat surfaces that get revealed when you chop away part of the 3D object. That's called a cross section. Okay? Now, the volume of a cylinder is the same formula as the volume of a prism. See how it says volume equals capital B times H? Capital B is the area of the base. So a cylinder and a prism both have two bases. They are congruent, so they're exact copies of each other, and they're parallel to each other. So if you look at the cylinder here, see the circle on top and bottom? You see how they're parallel, just like the ceiling and the floor of the room? Okay. And then you see how they're exact copies of each other, exact copies of circles? Those are the bases of the cylinder. Well, a prism, which we'll talk about a little bit later, has different types of shapes as its base. It could have triangles, it could have rectangles, it could have squares. A cylinder always has two circles as its bases. So if we think about the volume of a cylinder or a prism as the area of the base times the height, well, the base is always a circle. So we replace this here, this capital B, with this part in the parentheses here, pi r squared, because the area of a circle is pi r squared. So when I ask you to find the volume of any of these cylinders, once you look at it and you realize, oh, it's a cylinder, you're just doing pi r squared times h. This is representing the area of the base, the circle, and then h is the height. The height is the distance between the two bases. So if you look at these two circles, you see this segment right here? That's the segment connecting the circles. That's the height. If the cylinder is lying on its side, this is the height. Even though it's horizontal, that's the distance between the two bases, so that's the height. So, let's look at these. Pause it if you need to fill everything out if you want. And here we go. This is a cylinder. The radius of the base is 4. The height, the distance between the bases, is 10. So I go R4, H10, and then I write out, usually I would write out the formula, but since it's right here, I didn't rewrite it. But if I had a mixed bag of different types of questions, I would find the volume of the cylinder and I would write V equals pi r squared h, and then I would substitute these numbers in. And that's what I've done here. Okay? Now, sometimes we ask you for the exact volume in terms of pi, so you're going to have a pi in your answer. And sometimes we ask you to round. So here's what it looks like if you are getting the exact answer. Okay? So I go pi times r squared times h. Well, 4 squared is 16, so I have pi times 16 times 10. Multiply the two numbers, that's 160, and you just say 160 pi. That's the exact volume in terms of pi. Now, in the last section when we did area, that was all of our answers were squared. Volume, all of our answers are cubed. Okay? So they didn't give us a unit, so we're just calling it units. Units cubed. The exact volume, 160 pi. If you want me to round to the nearest hundredth, I just type 160 pi in my calculator and hit enter. Don't approximate pi, okay? Don't just put like 3.14. We want you to use the pi key in the calculator because that's the most accurate when we want you to round, and nearest hundredth is 2 decimal places. So these two answers are equivalent. You just have to look at the question and see which format we want the answer in. Sometimes we say exact, sometimes we say rounded. In this problem, the height is 12. This is the height. Now, this is not the radius. This is the length through the entire circle. That's called the diameter. So if the diameter is 10, the radius is 5. And what's our formula? It's right here. Pi r squared h. So we do pi times 5 squared times 12. And that's where we get the answer. Now multiply those, 300 pi. Again, if the lengths are centimeters, the volume is centimeters cubed. And then if we say, hey, why don't you round that for us? You would just type this in your calculator. Okay? Why don't you go ahead and pause it, try the next two on your own, show your work, then check back here and see if you got the same answer back. Okay, did you get some answers? Here's what I got. Again, for 3, height is 21, radius is 7, not 14. You gotta cut this in half and divide by 2. The exact answer, we just leave the pi and multiply the numbers. If I want the rounded answer, I do this times pi. Here we are, units cubed. For number 4, they told me the radius is 5 and the height is 15, so I just substitute those numbers in. Exact answer keeps the pi. Rounded, I do this times pi, and I get this. And this one, they told me centimeters, so it's centimeters cubed. Now the next one is a little bit trickier because you have to kind of go backwards. So in this one, we tell you the volume, and we ask you to find the radius. So what I do is I say, okay, this thing is a cylinder, and I believe yours might say inches, so you're going to want to cross out and put centimeters so that these match up. Okay, we didn't want you to do conversions on this. So it's a cylinder. The volume of a cylinder is pi r squared h. So now I'm going to substitute everything that I know. Well, I know the height is 18, and I know V, the volume, is this. So I substitute 354.96 in for V right here. And then pi, I just leave. Pi is pi. R squared, I don't know what R is because that's what I'm trying to find. So I leave that. but I do know h. H is 18. So if you look here, I'm trying to solve for r. So I want to get r isolated. Well, I have r squared times pi times 18. That's 18 pi r squared. So how can I get r squared by itself? I'm going to divide both sides. So here, see if this helps you. So this is what we're starting with. So now I need to divide by 18 pi to get r squared by itself. So that's what I did there. Okay? Now, I don't want to keep rounding. So instead of typing this into my calculator, 354.96 divided by 18 pi, I just leave it right there. I'm just going to leave that. And now I have r squared. Now, how do I go from r squared to r? I need to square root both sides. So if I square root r squared, I get r, and if I square root this fraction, I get this whole thing under the fraction. So here's how I would do that. No matter what calculator you have, I only want to round one, so I don't want to have to keep typing things in and approximating. So I would go like this. You hit 354.96 divided by 18 pi, enter. Now, you should check and see if you're getting the same answer with me. I've seen once or twice on some calculators where you'll have to actually put parentheses around that 18 pi in that situation before you hit enter. So you would go 354.96 divide parenthesis 18 pi parenthesis enter. Check and see if you ultimately get the same answer as me. But anyway, what I do is I divide this by 18 pi and I have an answer in my calculator saved that's not rounded. Okay, so then I would go to square root of the answer, and that will allow you to only have to round one. So I'm going to show you what that would look like. So this is a graphing calculator, but again, this way will work also on a scientific calculator. Type it in, hit enter. So this was the part that was under that square root. Now, this new number is saved in my memory of my calculator. So what I'm going to do, since we needed to take the square root of that entire thing, I'm going to hit second square root, and then I'm going to go answer. Most calculators have an answer button, and in this case, it's referring to this saved answer right here. Okay, so now I'm going to hit enter, and it took the square root of this precise answer up here, so I only have to round once. So I'm going to round to the nearest hundred, which is this decimal place, so it's 2.51. Okay, so that's where I got this answer here for the radius. Okay, and it's in centimeters. And the final one, they're just trying to trick you because it looks like it's going to be different, but the height is the perpendicular distance between the bases. So if you look here, see this 8, see how it's perpendicular to the ground? 8 is the height. Even though somebody hit into our cylinder and knocked it so it's a little bit crooked to the side, it doesn't matter. The volume is still going to be measured by using this 8 as the height because it's the perpendicular distance between the two bases. Okay, so the radius is 3, the height is 8, and we just use our formula like normal. It's just pi r squared h. So the volume is going to equal pi times 3 squared times h. 3 squared is 9. Multiply these two numbers, you get 72. So it's 72 pi is the exact volume. That's centimeters cubed because it's volume. And if I ask you to round to the nearest hundredth, you would just do 72 times pi, enter in your calculator, and you round to 2 decimal places. That's it. So that cylinder, we're going to learn a couple other formulas for different solids, and just going forward, just remember pi r squared h. It's the area of the base times the height.